A series of iCampSA lessons. So today we'll be covering your cosine rule proof, right? So we'll be covering two cases of cosine rule proofs, which the first being your acute-angled triangle proof, and then your obtuse-angled triangle proof, right? So we'll be covering both those proofs. So let's see how we can go about that. So we will start with the first being for your acute-angle, right? Your acute-angle triangle, right? Proof. Now let's draw the triangle, right? So let's first the most important thing is what we are required to prove, right? What we are required to prove. So the cosine rule says if you have b squared, it's going to be equals to a squared plus c squared minus 2ac, your cos of angle b. Right, so this is what the cos rule says, and this is what we are going to try to prove, right? Obviously this does not mean the others are not true, but for the purposes of this lesson, this is what we are going to try and prove. Even if it started with a squared is equals to b squared plus c squared, it would have been true. It just depends on how you choose to name your angles and your sides. Right, so let's get into it, right? So remember, we are trying to prove for what? For acute-angled triangle, right? So let's draw our triangle. So this is what our triangle will look like. And then you have your A, we'll have our B, we'll have our C, right? Remember, the most important thing when you are doing this is how you name your sides, right? When we are doing your trigonometry, especially your rules, right? How you name your side. So the side opposite to angle A, right? So you can see it, you name it like this. So the side opposite to angle A, it's gonna be called your side A, small side A. And the side opposite angle B, it's gonna be angle B. And then the side opposite to angle C, it's gonna be C, right? So that's how we are gonna do this, right? That's how we're gonna do this. Great. So that means that you have your A, right? And then this is gonna be your B, and then this is gonna be your C, right? This is gonna be your C. So in order for us to do this, we need to construct a line. Remember, for us to apply our trigonometric ratios, you need a right angle triangle, right? The same as when we did our cosine or sine rule, we're gonna do for our cosine rule, right? So this is the line that we are going to construct, and this is gonna be line H, right? And then it's going to cut this. We can just draw one right angle triangle. Then now we have right angle, we have right angle, and then this is gonna be your angle, and this is gonna be your angle, right? So now what we are going to focus on, the first triangle that we're gonna focus on, is this one, right? It's gonna be this one, right? So we are going to say, so we can just call this point D. Great. So now we are going to say in triangle ADC, right? In triangle ADC, right? And we're going to apply our Pythagoras theorem, right? So our Pythagoras theorem says your r squared, right, or your hypotenuse side is going to be equals to the sum of the two other sides. So in this case, if we are focusing on this triangle, we are going to have b squared is equals to h squared plus dc squared, right? So we are going to have b squared is equals to h squared plus dc squared, right? Plus dc squared. But what I want to do, right, I want to write dc, right? I want to write dc in terms of a, right? So remember, a represents this entire side, right? A represents this entire side, right? So what I want is to represent dc in terms of a, right? And the way I'm going to do that is your BC, right? Your BC is equals to what? Is equals to your BD plus DC, right? But what is BC? BC is A. And what is a BD? BD, we don't know BD. So it's just going to be BD. And then we also don't know what DC is. Right, so I want DC to be the subject of the formula. So I'm going to have DC is equals to, it's going to be equals to A minus BD, right? And then I'm going to take this and substitute it into here, right? So now I'll be left with, now I will have b squared, right? Now I'm substituting. Now I will have b squared is equals to h squared plus, remember what is DC? DC is A minus BD. So I'm going to have A minus BD all squared, right? And then from here I can simply simplify this, right? Because it's a difference of two squares. So I'm going to have b squared is equals to h squared plus, this is going to be a squared minus 2ab d, right, plus bd squared, right? And then this is going to be my equation 1, right? This is going to be my equation 1. So now I'm going to look for, I'm going to work on another triangle, right? I'm going to work on another triangle, which is going to be this triangle, right? So I will write here, that's now I'm in a triangle ABD, in triangle ABD, right? And then I will use the same Pythagoras theorem. Pythagoras theorem is going to say c squared is going to be equals to h squared plus bd squared, right? Now I want you to notice something, right? I want you to notice something. Here I have bd squared, and here I also have bd squared, right? So in both these equations now I have something in common, right? So I can make one subject of the formula and substitute it into the next, right? So I'm going to make this one, I'm going to come here and make bd squared to be the subject of the formula. So it's going to be bd squared is equals to your c squared minus h squared, and this is going to be equation 2, right? Now I'm going to substitute equation 2 into 1, right? So I'm going to substitute equation 2 into equation 1, right? And now what I'm going to be left with, it's going to be your b squared is equals to your h squared plus a squared minus 2a bd plus What is BD squared? BD squared is actually C squared minus H squared, right? Notice how I did not put brackets because of the positive sign, right? So it would not affect anything inside the bracket. Great. So now I have something in common, right? I have something in common. So I have H squared and I also have H squared, right? But notice how this H squared is negative. So I have positive H squared, I have negative H squared. So this and that will cancel, right? So I'm going to have this cancelling with this. And then now I am left with your B squared is equals to your H. Nope. It's going to be your A squared minus, nope. It's going to be plus C squared minus 2ABD. Right? So if you look at this, right? If you look at this and you look at what we are required to prove, right? We are almost there, right? We are almost there. So what we need now, we need your BD, right? We need your BD to be written in terms of C cos of angle B, right? So in order for me to do that, I am going to look at, remember it's BD, right? And I need cos of angle B. So I'm going to look at this triangle, which will give me angle B and BD, right? So now what I'm going to say in triangle ABD, right? In triangle ABD, right? Now I'm just going to apply my cos, my trigonometric ratio, right? So it's going to be cos of angle B is equals to, remember cos is adjacent over hypotenuse. So what is your adjacent side? Adjacent side, it's BD. And then what is my hypotenuse? My hypotenuse is C, right? So remember, I want BD to be the subject of the formula. So I'm going to multiply by C both sides, multiply by C both sides. And then this and that will cancel. And then I'm going to be left with BD is equals to your C cos of angle B, right? And then now I have two. So I have this, right, which I can easily call as equation 3. I can call it equation 3, and then I can call this equation 4, right? So what I'm going to do, I'm going to substitute equation 4 into equation 3 and see what I'm going to be left with, right? So I'm going to substitute equation 4 into equation 3, right? So if I go and I look back, now I'm going to have your B squared is equals to A squared plus B squared minus 2. Nope. It should be AC squared minus 2AC. Nope. It's not 2AC. What is BD? BD is C cos B, right? So this is going to be C cos B, right? So if you look now, you have something similar. So this definitely looks the same way as what we were required to prove, right? So this is how we prove right? So this would have been true even if you were using even if it was written like A squared is equals to B squared plus C squared minus 2A minus 2BC cos of angle A, right? You can still prove it in other ways, but just make sure that when you prove it in other ways, it still applies, or it still looks the same way as this, just that you name your triangle in different ways, right? just be careful of how you name your triangles, especially when it looks different. Great. So now let's look at how we can do this for obtuse-angled triangle, right? So I'm also going to start on a new page, right? So I'm still proving cosine rule, right? It's still cosine rule proof. However, now I'm just doing it for obtuse-angled triangle. Right, so still going to have the same, right? Let me just draw my triangle here. Right, so I'm going to have my angle A, I'm going to have my angle B, I'm going to have my angle C, right? Remember how we name angles and how we name angles and sides. So the side opposite angle A, it's going to be called side A, small letter side A, and then I'm going to call this side B, right? This is going to be side B, and then this is going to be side C, right? This is going to be side C. So I'm still required to prove the same thing, right? So this is, I'm still required to prove the same thing, but in a different angle, in a different triangle. So I'm still required to prove that b squared is equals to a squared plus plus c squared minus 2ac cos of angle B. Right, so this is still what I'm required to prove. I should be able to do this. Right, so now let's go and see how we can do that, right? So as I have indicated, right, in order for us to do this, we always require a right angle triangle, right? So in this case, we have to construct a line, right? So this is the line that we are going to construct. Going to construct a perpendicular line. And then it's going to turn this into a right angle triangle, right? And then we can call this point D, right? And then this is going to be your line H, right? Remember, this is angle C, right? Angle C, that means that this angle right here, this angle right here, it's going to be 180 minus C. Right, so it's going to be 180 minus C. It's going to be 180 minus C. Right, so now what I'm going to do, I'm going to start with this triangle, right? I'm going to start with this triangle because it's this very same angle that will give me a b squared, right? That forms part of the subjective formula of what I am required to prove. And so I come here, I say in triangle ACD, right? In triangle ACD. So in triangle ACD, I use what my Pythagoras theorem. So it's going to be b squared is equals to my h squared plus my CD squared, my CD squared, right? So what I want is I want to write CD. I want to write CD in terms of A, right? I want to write CD in terms of A. So the way in which I'm going to do that is I know that BD is equals to my BC plus CD, right? So what is BD? BD is what we don't know, the unit or the variable, but we know BC is A, and we don't know what CD is, CD. So now we are going to make CD the subject of the formula because I wanted to write CD in terms of A. So it means that my CD is going to be equals to my BD minus A, right? And then I can take this into here, right? So now I'm gonna be left with b squared is equals to h squared plus, what is CD? CD is BD minus A, right? This is going to be BD minus A all squared, right? So now I have difference of two squares. I can simplify. This is going to be b squared is equals to h squared, right? And now it's going to be bd squared minus 2bda, right, plus a squared, okay, plus a squared, right? So I can just rearrange this. So it's going to be b squared is equals to h squared plus I still have my bd squared minus 2abd plus a squared, right? And I can simply call this equation 1, right? So now I go to the other triangle, which will be the bigger triangle, this one, right? So in triangle ABD, this is going to be in triangle ABD, right? So in triangle ABD, I will have c squared as my hypotenuse. On my opposite side, it's going to be h squared plus bd squared, right? Great. So I want you to notice the same thing here. I have bd as my subject of the formula. I have something common in between these two equations. I have bd squared here, and then I also have bd squared here, which means that I can simply make bd to be the subject of the formula, and then I substitute it back, right? So now if I make bd the subject of the formula, bd squared, so I'm going to be left with bd squared is equals to my c squared minus h squared, right? So this will be my equation 2, right? So now let's see. I'm going to substitute equation 2 into equation 1. So I'm substituting equation 2 into equation 1, right? So now I'll be left with b. I will have bd squared. I'll have b squared is equals to h squared. And then because it's a positive sign there, so just gonna write it as is. It's going to be c squared minus h squared, right, minus 2abd plus a squared, right? So here there's something common, which is h and h squared and h squared, but here it's positive h squared, negative h squared. This and that will cancel, so I'm gonna be left with b squared is equals to, I can just start with a. I can just take a and write it first. So it's gonna be a squared plus c squared minus 2a what bd. Great. So now I have bd, right? I have bd, and what I want is I want to have cos of angle b. So where does bd, where is bd? So bd is in the big triangle, which is abd. So while I'm still in the same triangle, so I can just say that remember I'm focusing on this angle, so I can say cos of angle b. So cos of angle b is equals to adjacent over hypotenuse. What is my adjacent side? My adjacent side is going to be bd, and then what is going to be my hypotenuse side? It's going to be c, right? So now I can multiply by c both sides, c, and also multiply by c here. here I'm going to multiply by c. So this and that will cancel, and then what I'm gonna be left with is a BD that is equals to your C cos of angle B, right? So this is what I need, and this is what I'm gonna substitute back into that equation, right? So I can just call this equation 3, and then this will be my equation 4, and then I just substitute equation 4 into equation 3, right? So I'm just gonna substitute equation 4 into equation 3, right? So what I'm gonna be left with is b squared is equals to a squared plus c squared minus 2a. And then in space of BD, I just substitute C cos B. So it's C cos of angle B, right? So this is me having proven the cosine rule. So this is where it ends. Right? So these are the two cases of solving cosine rule, right? So if you want to challenge yourself, you can challenge yourself by changing the sides and the angle positions. So for example, if you can just put B here and just put A and just put C here. So it's gonna be ABC, and name angles the same way, right? So this is gonna be side C, this is gonna now change and be side B, and then this is gonna be now side B instead of A, right? So you can challenge yourself and see if you can still prove it the same way as I have done, right? Great. So now we're gonna look into other problems. We're gonna go straight into problems now. Thank you for tuning in. This is how we solve your cosine rule. Right, this was for Acute-Angled, right? And then now this is for Obtuse-Angled. Great. Thank you for tuning in. See you on another video. If you have not subscribed, please make sure you subscribe, like, comment, and share the video.